Good morning, it's Mrs. Pasternak, and today I'm going to be talking about exponential functions. And again, this concept I'm going to be spending several days on, so this is the first day of many that I'm going to be talking about it. So why do we have such a low x-axis to graph exponential functions? Make a table of values for the equation y equals 2 to the x power using the domain from -2 is less than or equal to x, which is less than or equal to 4. So basically the domain is telling you exactly how to set up your table. So it's telling you which x values you're going to use, and it says that you're going to use from -2 all the way to +4. So we're going to plug this in our calculator, and it's called exponential because it's raised to a power, an exponent. So on our calculator, we're going to turn on y equals, and we're going to clear out anything that is in there. And you're going to plug in 2, and then a caret, and then an x. So it's 2 to the x power. And then you're going to hit second graph to access a table. And you're going to start looking where it says -2. And it says 0.25, or basically 1/4. -1 is at a half. 2 to the 0 power is 1, because anything to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. 2 to the third power is 8. 2 to the fourth power is 16. So let's go back up here to the 2 to the -2 power. As a 7th grader, we taught you that it's 1 over 2 squared, which is equal to 1/4, which is exactly how we got 0.25. 2 to the negative first power is the same as 1 over 2 to the first power, or just 1/2, which is how we got 0.5. Okay, so we're not actually going to now graph this so you can see what the parent function looks like. So we're going to head over to -2, 1, 2, and we're going to go to like a quarter, which is tiny down here. -1 is going to be a half. 0, 1 is the y-intercept. 1, 2, 2, 4. So it's going to rise pretty quickly here. 3, 4. And then 3, 8, 4, 5, 6, 7, 8. And 4, 16, 9, 10, 11, 12, 13, 14, 15, 16. So how this works is that if you keep looking on your negative values, is that it never touches 0. So I keep going, and it's like goes to like a really, really small number. So this is how it looks. So it actually never ever crosses the y-axis. I'm sorry, the x-axis. It does cross the y-axis as 0, 1. And this is y equals 2 to the x power. And this is the parent function for the exponential function. That's what we're learning about. So it says, graph the function. Will this graph have an x-intercept? So no. It will never touch the x-axis. What is the y-intercept? 0, 1. All right, so let's play around with this function a little bit. Let's sort of see how it looks. So let's take a look at the next page. Graph this function on your calculator using y1. So we did that. So we can just hit the graph button, and that's in blue. And if you look at it, it looks like it's almost laying on the x-axis, but it actually never touches it. It just gets really, 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 really close to it. This is the exponential parent function. As b increases larger than 1, it stretches closer to the y-axis. Okay, so the b is the term that's being raised to the x power. So as that increases, there's a Desmo link for you to play with, which I'll attach to my Google Classroom. And we're going to try it out with the next one. So now it wants you to do y equals, and under y1, we're going to leave 2 to the x, but under y2, we're going to do 3 to the x power. So now we're changing the b to a higher number. So I'm using 3 caret x, and I'm hitting graph. So my blue function stays. My red function is getting closer to the y-axis. So that's sort of what's happening. Stop and drop. What do you notice when we increase the base? So I'm going to say it is closer to the y-axis. You can even use the word stretches. Okay, and you can try that out with other numbers if you wanted to. So like we're going to try this one. Use your calculator to graph the following. So I'm going to hit y equals. I'm going to clear everything out. And under y1, I'm going to do 5 caret x. And then I'm going to hit the graph button. So what do I notice now? It gets even closer. Who? Closer to the y-axis. Okay, what if we put a negative sign in front of it? So I'm going to leave that under my y1. Under y2, I'm going to do negative 5 caret x. And then I'm going to hit the graph button. So if you had to guess, and I threw a negative sign in front of it, like we've learned in the past, it's reflecting over the x-axis. And that's what it looks like on my calculator right now. Let's say I put in y equals, and I'm going to do a third one now. And this time I'm going to do in parentheses the reciprocal of 5. So it's 1 divided by 5, close parentheses, caret x. And then I'm going to hit the graph button. So what happens? So this is reciprocal of b. So b was 5. And then we got 1/5. And it reflected over the y-axis. Almost looks backwards, and it's in black on my calculator. All right, so let's play around a little bit here, and let's go back here. And we're going to graph a few graphs. We're basically going to have 3 functions. We're going to have f of x, g of x, and h of x all on our graph grid here. So just got to be careful when you're graphing, and we're going to talk about what that means. Okay, so f of x equals 2x. That's the parent function. So we can clear out everything that we have on here, my y1, y2, y3. We can go back and we can plug in 2 caret x. And we can hit the table if you want to get some points. So you know how to graph this again. So we had -2 1/4, -1/2, 0, 1, 1, 2, 2, 1, 2, 3, 4, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 4, 16. Okay. So this was the parent function that you and I graphed in the do now. And I'm going to just call this f of x. Who is your original y-intercept? 0, 1. Okay, so what we're going to do is we're going to add a +4 for my g of x. So if you had to guess, and it was outside, because it's not by the exponent, but it's outside of it, and outside tells the truth, outside has to do with vertical shift up or down. So if you had to guess, what would your new y-intercept be? If it was 0, 1, and then we added 4 to it, you want to guess? 0, what? Hopefully you're saying 5. So let's actually plug that in. I'm going to plug that in my calculator here. I'm going to just edit where it is on the y1. So it says 2 to the x power, and I'm going to write our all the way over and hit +4. And then I'm going to hit second graph, and I'm going to get some points to graph it at. So for -2, I have 4.25. So it's basically 4 up from this. So we have 1, 2, 3, 4.25. It's somewhere over there. This one's 4.5. Everything shifted up 4. 0, 5, like we predicted. 2, 3, 4, 5. This is going to be 1, 6, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. I can't get this one. This one's not going to fit because it's like 20. So it's going to go like that. And that is my g of x. So if you look here, this is coming really, really, really close to 1, 2, 3, 4. So y equals 4 is like the line that it's coming really close to. And we're going to call it, who is this? G of x. So g of x, it doesn't touch y equals 4, but it comes really close to it. We call that an asymptote. That's a new word. It's a line that it comes really close to, but doesn't touch. That's the asymptote. Okay, for this, for g of x, or f of x, it was y equals 0, or the x-axis. All right, let's try h of x now. H of x is now, I'm changing the exponent. So I'm going to clear everything out that's here, and I'm going to plug in 2 caret, and then a little x plus 3. And that x plus 3 is small on your calculator. That's part of the exponent. So this is sort of the outside here. This is considered the inside the function. So I'm going to do that guy in red. And I'm going to hit second graph to get some points. So if I had to guess from the parent function, so inside lies, so if it says plus 3, it's not going to shift right 3, but it's going to shift left 3. So let's see if that actually works. So I'm going to start with -5, 1/4, and 1/4. 1, 2, 3, 4, 5, and 1/4. That seems to make sense. -4, 1/2. -3, 1. -2, 2. -1, 4. 0, 8. 1, 16. So I'm going to graph this. And again, it's coming really close to y equals 0, or the x-axis. That's the asymptote. And then h of x crosses the y-intercept. So what happened to the y? The y-intercept is now 0, 8. And it... So from here, the y-intercept, it was here, and it just shifted over, okay? It shifted to the left 3. The y-intercept, though, looks like it increased by 7, which is a little... Okay, so the f of x shifted left 3. All right, let's try the next one. So we have silver and gold already. Okay, so we're actually, silver and gold are all the same. So we're all going to do 6, 7, and 8. I don't really know why there's there's silver and gold here. So we're basically going to say goodbye to that. And we're all going to be doing 6, 7, and 8. So this one has 2 things going on with it. It has x plus 1 and a plus 3. It has an inside and an outside. It's giving me the domain of -1 to +5. So we're going to start there and graph there. I'm still going to put arrows on my stuff, even though it's giving me domains. I think these are just pretty numbers to actually graph. So I'm going to head into my calculator, and I'm going to go into y equals. And right now I currently have 2 to the x plus 3 power. So you have one option. You can clear it all out and start all over again, or you could just change that plus 3 to a plus 1. You do need to right arrow out of that in order for it to get out of the exponent to hit in the +3. That's very important that you make sure you do that correctly. So the x plus 1 on your calculator looks really tiny, like an exponent, and the +3 looks like the same size as the base, the 2. And then you're going to hit second graph, and you're going to generate a table, and I'm going to start with the value of -1. So the number that goes with -1 is 4. I'm going to keep going. 5, 7, 11, 19, 35, 67. This is clearly not all fitting on my graph. But let's see what we can fit. So let's do -1, 1, 2, 3, 4, 0, 5, 1, 7, 6, 7, 2, 11, 8, 9, 10, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I could put it up there. I'm going to go back here anyway, even though it didn't ask me, but I'm going to look on my calculator for -2, and -2 is at 3.5. 1, 2, 3.5. And if you look, it's getting really close to the 3, but not actually touching it. So the asymptote here is y equals 3. And this is s of x. The asymptote is y equals 3. So it's getting like really close to y equals 3, but not touching it. Let's talk a little bit more about this. The y-intercept is at 0, 5. And what's happening from the parent function? From the parent function, if you're looking at, so inside lies, outside tells the truth. So it is going, shifting left 1, up 3. All right, so that's 6. Let's take a look at 7. So 7 has 0.5 to the x power. So the b got smaller. Let's see what happens with that. So I'm going to clear all of this out, and I'm going to plug in 0.5 caret with a little x, and I'm going to hit second graph. And it's telling me to start at -3. So -3 is 8, 4, 2, 1. 1 is 0.5, 0.25, 0.125. So this time, and again, this is, I could rewrite this. F of x equals, instead of writing 0.5, I could write 1/2 to the x power. So do you remember that this is the reciprocal of 2? And we said if it's the reciprocal, if we went back, way back when in the beginning, we talked about this, I think it was on question 2, it flipped over the y-axis. So let's see if that actually is true. So -3, 8, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. -2, 4, 1, 2, 3, 4. -1, 2, 0, 1, 1 1/2, 2 1/4, 3 1/8. So it's getting really close to the x-axis. What about -4? 16? So that's 8, 9, 10, 11, 12, 13, 14, 15. I could throw one more in there. So again, it's getting really close to the x-axis, or y equals 0. So the asymptote is y equals 0. The y-axis, the y-intercept, sorry, I'm saying that wrong. Did I say that wrong on the prior page? Nope, I did it right. Okay, so y-intercept is still 0, 1, still the same y-intercept. What happened? It reflected over the y-axis. So what's weird about this is that there's not having a negative sign. It's just that the base is becoming a fraction or reciprocal, and then it reflects over the y-axis. All right, let's check out question number 8. So this time we have f of x equals 1 1/4 to the x power, or 1.5 to the x power. Let's see how that looks. So let's clear this out and let's plug in 1.25 caret x and let's generate a table. And this is asking us to start at -3. If I start at -3, I got 0.512. So I'm going to do this in red. For -2, I have 0.64, 0.8, 0, 1, 1.25, 1.5625, 1.9531. So these are going to be a little more challenging to graph, but we'll do our best. We'll see what happens. Okay, so -3, 1, 2, 3 is about a half, about. -2 is a little bit higher than that. -1 is almost at 1, it's at 0.8. 0, 1. 1, 1 1/4. 2, 1 1/2, about. 3, a little under 2. So if you're looking at this, it's basically going slowly, never crosses the x-axis. It basically is going slowly up. Okay, so what happens? So the asymptote is y equals 0 for the x-axis. The y-intercept, still 0, 1. And by changing the b, it stretches it. It's kind of like a dilation. It's stretching it. All right, so let's sum up what we learned today about the exponential function. When the base is larger than 1, is the function increasing or decreasing? The base is greater than 1, like 2 to the x. It was going like this, from left to right. So it is increasing. When the base is smaller than 1, like we had a reciprocal, 1/2 to the x power. So like this was y equals 2 to the x power. If y equals 1/2 to the x power, we saw it went like this. So the y values are decreasing and it's reflected over the y-axis. When the coefficient is negative, when it's less than 0, the exponential function reflects across the x-axis. When we add the exponent, we shift it. When we add to the exponent, we shift it horizontally or vertically, and it lies. So we're shifting it horizontally, it's moving right or left, and it's lying, so it's the opposite. When we add to the function itself, that's on the outside. Call this outside. I'll call this inside. It is shifting it vertically, up or down. All right, big idea, and we're all done. So let's take a look. The y value for an exponential function will never reach 0. That's what we call asymptote. That's for the parent function. You don't need a third and fourth quarter, okay? Well, you don't need that for the parent function, because the parent function is only in the first and second quadrant, except if you're reflecting it over the x-axis. Then you're definitely going to need the other quadrants on the graph. Okay, so I'm all done here. You have a homework to do. And then I'm also putting in there the unit check on the 5 other functions. So this lesson is not on my unit check. That's a Google form, and that Google form is going to be due on Friday. So please do your best. I do have a Google Meet on Thursday. If you have questions on the unit check, I highly encourage you to look at it between now and then. And if you have any questions on this homework assignment that goes with this lesson, I can answer it also on Thursday's Google Meet. Have a great day.